Hey, what's up, guys? This is Chung here again. So today, let's take a look at this Codeforces problem, string coloring hard version. So a few days back, we discussed about the easier version. So if you guys still remember that easier versions, basically what that problem is telling us is the similar as this one. You're given like a string and consisting n English lower English letters, and you need to color those strings. You need to color each colors the whole characters. You know, the same character, same letters can be colored with different or same color. And and after coloring, you can swap any two neighboring characters or letters that have different colors. And your goal is to make the string a sorted string, basically sorted in alphabetical order. And yeah, and for this one, your task is to find the minimum number of colors which you need to have, right? So that you can make the string make the string assorted after coloring. And the input is like this. So this is the first one is the total length of the string. Second one is the string itself. And then the output is the first one is the total colors we need, right? The minimum colors we need. And then the second one is the color for each of the character. Mm, yeah, so this one actually is like a generalized version of the easy version. And so for the easy version, you're only allowed uh, to do a to use two colors, and your task is to check if the current string can after using these two colors, and you need to find a way to color the current string, and then you need to return if the current string can be sorted after coloring using those two colors. And if you remember, how did we solve that problem? Basically, we maintained two variables. So the first one is the max, right? The max letters. And then the next one is second max character. And if the current letters, right? Basically, if the current letter is greater than the max characters, and then we'll basically color the current letters to letter one, because one means that's the base colors, which means that we don't need to swap the current letter, right? Because the current letter is greater than all the previously letters. That's why we do a one. Else, right? Else, if the current letter is smaller than the max C, but it's greater than the second max C, then we'll mark color that character with color 2. Of course, after that, we need to update both the max C and the second max C accordingly, right? And then, but then if there's another else, which means that, if the current letter is smaller than both the max C and the second max character, then we'll return false, because this telling us we need a third color to color the current letter, so that the letter can be sorted. And why is that, right? So let's draw an easy some diagram here. So let me remove this part. What's this one? Okay. Mm. So let's say we process the letters one by one, right? So let's say we have a. So for A, for the first one, right, we can always paint that one to color one. And then for B, right? So for B is the maximum character, which means that we can also use color one, because this one doesn't need to be swapped. similar as C1, right? And then D1. And then let's say the next one is S, right? Still, right? It's 1 because they're increasing. Now let's see that the next one is I. Okay. So, oh, by the way, so once while we're maintaining putting 1 here, right? So we have a max characters that's going to be updated all the time. So we have A, then we have B, C, D, S, and at this moment, the max C is S. Okay, and now the next one is I here, right? So I is what? I is smaller than the max C. Okay, right? But that's why we know, and there is no second max values here, right? That's why let's say we have a second max, right? Because at the beginning there's nothing here. That's why for the I here, since it's smaller than the max C here, we have to use another color. That's why we need to do a 2 here, because then we can swap this I with this S to the very beginning. To Not to the beginning, but after swapping, I will appear before S. Okay. Okay, and then let's see the next one is what? The next one is K. So what happens? Oh, and after this one, so the second max element will be what? Will be I in this case, right? And then the next one is K. So K is what? K is smaller than S, right? And then which means that we have to make it a color different as S. And then how about the second one? Is the K smaller than the I? No, K is greater than I. So which means that we can simply put a 2 here. The same like color as I. So the reason being is that, since K is greater than I, which means that, K doesn't need to swap with I, but since K is smaller than S, which means that, K still has to be swapped before S. That's why we have to use a different color than S, which is 2. Okay. And let's say the next one is J. So how about J, right? Now, okay, so again, so this one will be to K. The second max value will be K. So how about the third one, which is J, right? J is smaller than S, and J is also smaller than the second max, which is K. And then that's why we need like a third value, a third color, right? So I know this is also kind of obvious, right? Because since J is smaller than S smaller than K, which means that we need to somehow move the J before S and the K. Yeah. So since S has color 1 and K has color 2, and to be able to swap J ahead of both of them, right, we need this one to be a color 3 here so that they can be swapped. So here, I think you guys already seen a pattern here, right? And then the next one, right? Let's say what's going to be the next one. Um, so for each of the letters, basically we'll be comparing with this the maximum uh, letters, right? So we're maintaining like a maximum letters, the sequence, right? From the first, the biggest to the second biggest, third biggest until to what? Until to 26, until to 26, yeah, 26 max. And so for each of the letters, right? We're comparing to see if there's if the current letter is greater than any of the max values here. If it is, then we can mark this letter to be the same color as that one. Otherwise, if none of the existing colors, right? If none of the existing colors is smaller than the current one, then we need to add a new color, which means that we need to append a new like entry to this current list. And the maximum entry colors we need to color the entire string will be 26 because there are only up to 26 lower English letters. So the maximum color we need is 26. All right, so yeah, I think with that being said, right, I think we can just start coding. Basically, I'm going to use the a vector of the of vector of char to store the current uh, maximum character for that for a certain sequence, right? Basically, the first element in that vector represents the first color, which means the biggest character, and then the second element in the vector represents the second max uh, characters, which has the second color, and so on and so forth. And every time for colors, for every time for for new letters, I loop through this vector, the color vectors, from the biggest to the smallest characters, and then we'll just use that. And then since this 26 is like is a constant, it's a limited size, right? So that's why, let me see here. We can solve this problem in O of n time because the input is 10 to the power of 5, right? And for each of the letters, right, we only need to loop through at most 26 times. Yeah. So I think we can just start coding. So first we have an n here, and then we need a vector to help us store the colors, right? The current colors, and for each color, what's the maximum characters for that color? Okay, and then we have string s, right? So to read that value in, right, we have this n s, and then we also need the answer, right? So the answer is going to be the max n. Okay. So for int I equals 0, and this one's smaller than n. Um, I'm creating like a Boolean flag to represent if we need to add a new color. I mean, there could be other solutions. I'm just using my own like ways to solve this problem. And so basically, the colors vectors stores the colors we have been using so far. So for each of the colors from 0 to see sorry dot colors smaller than colors dot size, right? And then C plus plus. So, and if the current letters, which is SI, right, is either equals greater than the current colors of C, then we know, okay, we can color the current letters to be the same color as this one, right? Again, because the current letter is greater than this one, which means that we don't have to swap the current one with this color, right? That's why we can do an answer dot I, right? So this is the answer we stored our final answer. It's going to be the current color. I do a C plus one. So because the colors, I'm I'm using like a zero based, but to the final answers it's one based. That's why for the color zero, I always add one so that it can be transformed to one based. And then after that, we also need to update the biggest character, right, for the current color, right? So in this case, it's SI, right? And then for a new color, right? So we have a new color equals to force because we don't need a new color. We can just use the existing color to color the current one. Do a break. Okay. So after this for loop, right, we simply do a if check. Basically, if we need to use the new colors, which means that the answer I will be the colors dot size plus one because we need to introduce a new color, which that's why we need the size of this one plus one. And then we also push uh, the current letters, right, to be the value of that letter of this new color. Yeah, and so we just do the output then. So the first one is the size, right, and then the for loop to print out all the colors. Okay. Yep, I think that's it. And let's see, run this one. 112 121 121. Okay, so this is right. So the second one, actually, the second one is not the best answers because we don't have to color this in this way because for A B B C B B, right, we can just color everything until B with color 1, right, and from C to C with color 1 and B we color this to B with 2. And let's try this one. This one should be okay. Oh, yeah, I copied the wrong input. 1 1 1 1 1 2 3. Yep. The last one is this one. It's an increasing string. Let's see. What do we have here? Yeah, so it's all ones, which is correct. Yeah, so I think this one works. The So just to recap, right? So for this problem, it's a generalized version of the easy versions, which means that we need to maintain like a vector, or you can use a map, or doesn't really matter. But the key point for this problem is that we need to maintain the maximum characters for each of the color, and then for every new letters, we'll compare we'll use the letter to compare with the from the first colors max color the max character to the last one, and as long as we can find uh, like a color that whose max letter is smaller than the current value, then we can just use that color to mark the current letter again, right? Because the since we have already guaranteed that for the for all the previously for all the previous mm, colors, we're guaranteeing that those colors or those letters can be sorted, right? So for example, right, so we have a K here, right? And then so the K we mark as 2. So why is that? Because we know, from A to I, from A to I, they can be sorted by using the one, two colors, and by using the same colors as I, but different color as the previous one, we're also making sure that with for the current letters, we can also make sure, right, this one can be moved before the S, while we're not introducing, while not using new colors, since we're going to, since we're calculating the minimum colors we need to use, right, so that the string can be sorted. That's why, we only introducing a new colors when we have to. Otherwise, we just reuse previously used colors while maintaining the validity of this string here, just like what we did for the letter K here. Yep, I think that's it for this problem, and hope you guys like it. And thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.